Hi friends, welcome to SSC JE Electrical. This video is regarding measurements important previous questions. This is the part 4 video. Regarding part 1, 2, 3 videos links I have given in the description. You can go through it. See here. Which one of the following type of instrument does suffer from error due to magnetic hysteresis? With the magnetic hysteresis, which one of the following instrument reading will be affected? See here. In case of moving iron instrument, there is a moving iron material. This is a moving iron material. This is a moving iron instrument arrangement. Okay. When there is a moving iron material, it will move like this. It will move like this. Whenever the current is flowing in this, then what happens? The flux will produce. The flux will produce. This flux will getting connected with this moving iron instrument. Therefore, it keep on moving based on the flux producing. Okay. So, due to this moving iron material, hysteresis loss will occur in this. Hysteresis loss will occur in this. With this, what happens? Frequency changes. Due to frequency changes, what happens? Impedance of the coil will change. Due to impedance of the coil change, the reading of the instrument, whatever the needle it is moving, the reading will change. Like that, it will get affected. See here. So, which one of the following type of instrument does suffer from error due to magnetic hysteresis? Moving iron type instrument. Moving iron type instrument. In that, moving iron material will be there. Due to that, frequency changes. Due to frequency changes, impedance of the coil changes. Due to this, the reading of the moving iron instrument will change. Therefore, moving iron instrument get affected with the hysteresis loss. Okay. Next one. A potentiometer is used to measure the voltage between 2 points of the DC circuit, which is found to be 1.2 volts. Which is found to be 1.2 volts. This is also measured by the voltmeter, which is found to be 0.9 volts. The resistance of the voltmeter is 60 kilo ohms. The input resistance is asking between 2 points. Between 2 points he has given 12 volts. Between 2 points he has given 12 volts. That there is a input resistance. After that there is a voltmeter connection. Okay. In that what he is asking? The resistance of the voltmeter given. This is 60 kilo ohms given. This is 60 kilo ohms given. And the voltmeter which is found to be 0.9 volts. 0.9 volts will be there here. 0.9 volts. Totally 12 volts. This is 0.9 volts. What is asking? The resistance of the voltmeter 60 kilo ohms. The input resistance is asking. We have to calculate the input resistance here. Okay. With this what we can calculate? Voltmeter resistance given 60 kilo ohms and the voltage given 0.9 volts. Based on this we can calculate. Carefully observe here. Total voltage is 12 volts. Total voltage is 12 volts. Across the voltmeter 0.9 volts is there. So remaining 0.3 volts where it will be? It will be around, it will be across the resistor only. That is 0.3 volts will be across this resistor. If we know the current, how much current is flowing through this resistor, we can easily calculate the input resistance. We can R equal to V by I. R equals to V by I. We know the voltage, that is 0.3 volts. If we know the current, how much current is flowing through this resistor, we can easily calculate the resistance here. Okay. So we have to calculate the current, how much it is flowing. How we can calculate? In this branch, there is a voltmeter with the resistance. So with this we can calculate the current, how much it is flowing. I equals to V by R. That is how much voltage given? 0.9 volts. That is 0.9 by how much resistance? 60K. 60K. Simplify this, we will get the one answer, that is 0.015. Directly I am writing 0.015 milliamps, you will get it. Okay. 0.015 milliamps, you will get it. With this we can substitute here 0.015, that is the resistance equals to V by I. How much voltage? That is 0.3 by 0.015. Simplify this, multiply with 100 on both sides. What you will get? 300 by 15. 15 to the 30, that is 20, you can get it. That is 20 kilo ohms is the input resistance. Hope you understood. Again I am repeating, see here. Across these two terminals, 12 volts given. Okay. Across the voltmeter, 0.9 volts given. Okay. Across the resistor, how much it will be? 12 minus 0.9, that is 0.3 volts. 0.3 volts will be across the resistor. If we know the how much current is flowing through this resistor, we can easily calculate the resistance, because resistance is equals to voltage by current. We know the voltage, that is 0.3 volts. If we know the current, how much it is flowing in the series branch, what happens? Whatever the current is flowing through this voltmeter, the same current will flow through this resistor. So that is why we are calculating the current. How we are calculating? Current is equals to the voltage across the voltmeter, that is 0.9 volts by how much resistance, 60 kilo ohms. Simplify this, we will get the 0.015 milliamps. 0.015 milliamps current is flowing through this resistor. Therefore 0.015 by, see here, R equal to V by I, 0.3 volts by 0.015 milliamps. Simplify this, we will get the, this one, 20 kilo ohms you are getting. Okay, so this is the correct answer here. Hope you understood. If you have any doubt, you can tell in comments. Okay, I will explain there. Next one. And next question is a little lengthy, so after next two questions we can discuss this. Okay, see here, 30th question. Which one of the following does employ null method of measurement? Which one employs the null method of measurement? See here, null method of measurement, not employing, very carefully you see, which one of the following does not employ a null method of measurement? For DC potentiometer we use null method. Okay, and for Kelvin bridge also we use null method. For AC potentiometer also we use the null method. Only for Megger we don't use. Regarding Megger we don't use null method. Regarding Megger, very important, previous class also I have discussed. For insulation resistance, for measuring insulation resistance we use the Megger. For measuring insulation resistance, for measuring, we can say, for high resistance, for measuring high resistance we use Megger. For which method we use for calculating high resistance also it will be asked in exams, that is loss of charge method also will be used. Loss of charge method will be used for measuring the high resistance, and direct deflection method also will be used. Very, very important, all these points are. Regarding Megger is used for measurement of insulation resistance, and Megger is used for measurement of high resistance. And what are the methods used in Megger for measuring the high resistance? That is loss of charge method and direct deflection method. All these are important. Okay, next one, resistance of the temperature. Here answer is Megger. Which one of the following does not employ null method of measurement? Is Megger is the correct answer. Next one, resistance temperature coefficient of the copper. Resistance temperature coefficient of copper at 20 degrees centigrade is 0.00393 degrees centigrade. For copper it is 0.00393 per degree centigrade. Very, very important regarding copper. Next one, when a multimeter is added to an existing voltmeter for extending its range, its electromagnetic damping, very important. When a multiplier is added to an existing voltmeter for extending its range, its electromagnetic damping, when you are adding this multiplier, when a multiplier is added to an existing voltmeter for extending its range, its electromagnetic damping will decrease. Important point, this is repetitive question, this one also. When a multiplier is added to an existing voltmeter for extending its range, its electromagnetic damping will decrease. If they ask you deflection torque will increase, but damping will decrease here. Okay, see here, previously we left one question. Now we can see now that one. See this question. During the measurement of low resistance using potentiometer, the following readings were obtained. During the measurement of low resistance using potentiometer, the following readings obtained. Voltage drop across unknown resistance is 0.531 volts, and voltage drop across 0.1 ohm standard resistance connected in series with the unknown resistance is 1.083 volts. Value of unknown resistance is asking. See, standard resistance is connected in series with the unknown resistance. See here, this is one resistance, this is another resistance. This is the standard resistance. Standard resistance is connected in series with the unknown resistance. For example, this is your unknown resistance. Standard resistance how much given? That is 0.1 ohm. This is 0.1 ohm given. Next, unknown resistance 1.0. see here, voltage drop across 0.1 ohm standard resistance connected in series with the unknown resistance of 1.083 volts. For example, this is V1, how much given, how much voltage? V1 equal to 1.083. Don't confuse here. Voltage drop across 0.1 ohm standard resistor connected in series with the unknown resistance is given. So 1.083 volts is regarding first one, 1.083. And in the first case, voltage drop across unknown resistance given, no, that is 0.531. That is this one, unknown resistance. This one how much given? That is V2, we can say V2 equal to 0.531 volts. 0.531 volts. Okay.